Welcome back to our troubleshooting series. Today we're talking distributed audio systems. This is another series of knowledge basics where we're diving into how to troubleshoot systems. Unfortunately, systems sometimes have problems and we gotta figure it out. So that's what this is all about. You're jumping in to a series, so make sure you watch the video and the audio and the distributed audio and the lighting. And if you haven't watched our introduction to prints, you really wanna watch that first because that's got a lot of information that's gonna help you understand what we're looking at today. So in today's episode, we're talking about distributed audio systems. Well, what is a distributed audio system? First, we're gonna ignore that for a second. We've got our source, our amp, and we've got speakers that are distributed throughout the facility, okay? Sometimes you might hear this as a 70 volt system, although it doesn't have to be 70 volt. We're not gonna get into engineering, but it's a distributed system where we've got multiple speakers throughout the facility connected to one source, all right? That's the basics. So our problem number one, we've got everything connected and we've got audio in speaker one and we got audio in speaker two, but then audio drops going into speaker 3 and speaker 4. Down the chain, the audio has stopped, all right? So how do we begin to troubleshoot this problem? Well, the first thing that we're gonna do is, from a critical thinking standpoint, I wanna make sure that we help you understand that you start with the problem. You don't start somewhere else, right?
I know that.
If you got a speaker that's not working, the very first place you're gonna check is the speaker that doesn't work, okay? Now, distributed audio systems oftentimes are in the ceiling or they're pendants, they're high up in the air, they're kind of difficult to get to, so you wanna limit how much you're pulling speakers out. So if I know that speaker 4 is not working and speaker 3 is not working, I don't wanna start with speaker 4 because I might pull out speaker 4 and everything looks fine and then I gotta go to speaker 3. I actually want to start with speaker 3. And the first thing I'm going to look at is I've got this wire. This is my distribution wire. It's distributing my power and signal to my speaker that's coming in to speaker 3, and then it's coming out of speaker 3 into speaker 4. And I want to make sure that both of those inputs and outputs, that they look good. All right, I want to say, yeah, I feel confident that there's not a problem right here with speaker 3. If there's not a problem with speaker 3, I'm actually gonna go backwards to speaker 2. Because if you don't remember, speaker 2 is feeding speaker 3. So your problem very well could be right here, the output of speaker 2 is not feeding speaker 3 properly. And if it's not feeding speaker 3 properly, it's not feeding speaker 4 properly, all right? So I'm gonna start with speaker 3, but I'm also gonna remember that I shouldn't work backwards, I should work forwards.
Forward! Forward!
All right, I'm gonna work this direction towards my source and figure out where my problem is. Now, I might find my problem right here. And if this input is bad, that's also gonna kill speaker 4. But in this example, we're saying that speaker 3 is not working, speaker 4 is not working, and we found our problem in this distribution. This wire wasn't hooked up properly to the output of speaker 2. Okay, so this is a audio stops down the line troubleshoot issue. The next one is the audio stops one speaker in the line, okay? So speaker 1's fine, 3 is fine, and 4 is fine, but speaker 2 is not working. How am I gonna check this problem? Well, I'm going to start with speaker 2 because that's the one that's not working. And this is a more challenging problem to create in the field than the previous problem where they're not working down line. Normally, this is going to either be that the installer that installed it put the input and the output wire in the same port, which does happen. And so then therefore it's passing signal and it's bypassing speaker 2. And so this being bypassed, it's not, this isn't working, but it's still passing signal down the chain. Or you do have a bad speaker, which does happen, okay? So one of the ways that you could check to verify, do I have a bad speaker, is I could take my output out, and I could take this input, take it out, and I tie this input to this guy, and I bypass the speaker altogether. And if I can verify that that works when this is disconnected, then it gives me a good sign that this line is working fine. I don't have any problems with this line, and all of these lines are working fine, and my problem is actually right here. Now, I also want to rule out that these speakers are causing any problems. So when I go back to hook it back up, I'm only going to hook up speaker 2. I'm not going to hook up the output to speaker 3 yet. I'm going to hook up straight to speaker 2, and I'm going to plug it straight into the speaker, and I'm going to check, does speaker 2 work when it's by itself? Which is a different problem that we're going to get into in a few minutes, but it is something that could happen, okay? And if speaker 2 begins to work, now I know, okay, I've got a different problem. Or if I put this into speaker 2 and it still doesn't work, there's something called a tap on distributed audio speakers, and the tap tells the speaker what mode it's in. And we're gonna go into that in just a moment. So stick with this video, and we're gonna go over speaker tapping, but my speaker might not be tapped correctly. And so that could be another thing I would check. If I've checked all those things, speaker 2 still isn't working, I've got a bad speaker, okay? Problem number 3, all right? We have everything hooked up and none of our speakers work, okay? This happens, right? We're like, oh no, 1, 2, 3, 4, everything's bad. Well, I'm gonna start with where the problem starts. I'm gonna start with speaker 1 because the problem starts with speaker 1. The problem doesn't start with speaker 4. It starts with speaker 1, so that's where I'm gonna start. I'm gonna pull that speaker out of the ceiling, and I'm gonna make sure that this cable, which is my input cable that's coming from my amp, that's feeding everything, I'm gonna make sure that cable is connected properly. If that cable's not connected properly, nothing else is gonna work, okay? So this is gonna be the first cable that I'm gonna check to make sure that it's working. Once I plug it in, if it all starts working again, then great. Another thing I can do is I can rule out the line coming out of my amp by taking this home run and I can hook it up to a tone generator. And that tone generator is going to tell me, are my speakers fine and I have a problem between my amp and my source, or with my tone generator, are my speakers also not working? We're gonna show you a little picture somewhere over here of what a tone generator looks like. We often use fluke generators. And so you hook it up, it's got a 9-volt battery in it, and it makes a little noise, and it sounds kind of like a car alarm is what it sounds like. You gotta remember that it's only a 9-volt battery. It's not super strong, so it's not gonna be like really loud, but it should be loud enough for you to put your ear up near the speaker and hear if the signal is passing. We use this technique a lot because we want to know, do we have good speakers and we have a problem here, or if that doesn't work, then we definitely have a problem at our speaker location. Okay, so then let's assume that we put the tone on and we do hear signal coming out down our distributed chain. Now these are working with tone. Now I know that I've got some problems in this part of my signal flow. And I can check my amp, make sure that the Phoenix plug and everything's connected, make sure that it's in the proper mode, make sure that the output is looking at the right input, which happens a lot. Once I'm happy with my amp, then I'm gonna check at my source. And that might mean that I swap out sources to check to see if my amp is fine and it's receiving the right source and I've got signal down the line, okay? Once again, the principles stay the same. I'm starting with the problem and I'm moving my way down the chain. All right, our next one is when speakers are getting quieter down the line. And now this is when we need to talk about tapping. We have a speaker. This is a typical example of a distributed audio speaker. This is an in-ceiling speaker. And on this speaker, there is a tap right here. And when we're talking about tapping speakers, this needs to be set to the correct setting in order for your system to work down the line. Now, a systems engineer should be the one that advises you on what setting you should tap your speaker to. So in our previous example, we may have had a tap issue, or we're just gonna check our tap, but this problem is gonna be when the tap is for sure wrong, okay? So what's happening here in this example is our speakers are getting quieter down the line. Speaker number 1 sounds great. Speaker number 2 might sound great, or it's loud enough. You might not even notice that it's getting quieter, but when you get further and further away from the home run, it all starts getting quieter. That is a telltale sign that you've got something tapped wrong inside your speakers. We'd always tell you, make sure you start with the problem. Well, in this particular case, the problem might be all of your speakers. So let's show the example of what is happening here. In this example, we have a 100-watt amp. And in a 70-volt system, these speakers can request how many watts they want. In our example on the screen, we have 50-watt speakers. So what's happening here is every speaker is saying,
"Hey, Mr. Amplifier, thank you for giving me power, but I want 50 watts.
And they take 50 watts. And then they go to the next one, and then this one takes 50 watts. And then they go to the next one, and this one takes 50 watts. And they go to the next one, and this one takes 50 watts. Well, you may have noticed that 50 plus 50 plus 50 plus 50 does not equal 100. So our amp is underpowered for what all the speakers are requesting. So typically what happens is that speaker number 1, it gets all the power at once because it's the first one in the line. So it's nice and loud. Speaker number 2, it's also trying to get as much as it wants because it's not that far from number 1. And so it's also fairly loud. But what happens down the line is speaker 3 and 4 don't have enough power to be loud enough. And so they progressively just keep getting quieter until at some point you're just like, oh, these speakers don't work anymore. Well, they probably work. There's just no power going to the speaker for coming off of your amplifier. So that's normally gonna be that you've got a tapping problem. Whose fault is that? Well, installers, we can make mistakes, but if it's designed improperly, if the person who put the thing together doesn't tell you what to tap it, or they tell you to tap it at one setting, but there's not enough power in the amplifier, that's gonna become a problem. Well, then how do you fix that? You gotta know how many watts my speakers need to be tapped at. So in this example, let's say that we tapped these speakers at 16 watts, then yes, 16 plus 16 plus 16 plus 16 would be 64. 64 is less than 100. We would have enough watts in our amp to feed our speakers. So you would have to go back and just adjust every single tap. All right, guys, it's that time again. Story time with Bruce Gilson. You know, sometimes it really helps to hear people's experiences and what they've gone through out in the field. And in this one about distributed audio, we have done some absolutely massive distributed audio systems. We're talking about thousands of speakers in distributed audio systems. One specific system was in a gigantic horse arena, and it was literally a couple of thousand speakers distributed across acres and acres and acres of property. And man, when we got into turning everything on for the first time, it wasn't that there were a lot of problems. It was that when there was one problem, it affected a lot of things. And so it really became a big challenge to troubleshoot because we would be inside these facilities that are 300,000 square feet. And the distributed audio chain was, 28 speakers on one output of the amp. And that is really a great place that I had to learn, man, you've got to do this thing systematically. What happened is we turned on the system in these gigantic facilities, and unfortunately, my guys didn't come get me. They started working at the end of the problem. And they pulled down speaker, and then they pulled down speaker, and then they pulled down speaker, and they pulled down speaker. And by the time they talked to me, they had already checked over 30 speakers. And I walk into the facility, it was finished last time I was in the facility, and now there's speakers dangling everywhere out of the sky, and they just tell me, hey, I can't find the problem. So I had to show them, okay, we got to go back to the beginning. We got to go back to where the problem starts. So if the problem starts with speaker 5 out of 30 speakers, then let's deal with speaker 5. Let's not go to the end. Well, sure enough, we went to speaker 5. There was a bad Phoenix connection. The wires were out, and we just plugged it back in, and all of a sudden everything started working. Yeah, I mean, that particular job, that was just, unfortunately, because of the size of the system, it was days of troubleshooting distributed audio systems. So if you enjoyed today's video, make sure that you hit subscribe and you hit like. And if there was something you need more clarification on, well, put it down in the comments and ask me a question, and I'll get back to you.